Hello students. Today I will discuss about Cauchy's mean value theorem and L'Hospital's theorem. So here we discuss about the theorem. If phi x and psi x are both continuous in the closed interval a and b, x belongs to a and b in closed interval, and phi x first derivative of phi x and first derivative of psi x exists in the open interval ab for x belonging to the open interval ab, and if first derivative of psi x not equal to 0, anywhere in the open interval AB, then there exists a value xi of x, a value of xi of x between a and b, and between the open interval a and b, for which phi x minus psi x, phi b minus phi a by psi b minus psi a is equal to first derivative of phi xi by first derivative of psi xi. This is called the Cauchy's mean value theorem. We will prove this. And the second theorem, if further phi a is equal to psi a is equal to 0, and first derivative of phi psi x not equal to 0 in the neighborhood of a, then we will find out a limit. Then limit x tends to a, phi x by psi x is equal to limit x tends to a, first derivative of phi x by first derivative of psi x, if the latter limit exists. If we find this limit exists, then we will find out that this is equal, that the ratio of the two functions is a limiting value at a point is equal to its first derivatives ratio at the same limit point, and this is called L'Hospital's theorem. So we will prove this true theorem in this way. We consider the function fx defined by the equation. We defined fx in this way: phi b minus phi a minus phi b minus phi a by psi b minus psi a multiply psi x minus psi a, psi b minus psi a. So here, if we define this function in this way, so here this is phi x actually. This is phi x and this is phi x. So psi x, sorry, this is psi x. So here this will be psi x. So we will define this a function phi b minus phi x minus phi b minus phi a psi b minus psi a multiply psi b minus psi x. So now if we put a and b in place of x, if we put a or b in place of x, we will get both are equal to 0. If we put b, x is equal to b, then this is equal to 0, and if we put here x is equal to b, then this is equal to 0 and this is equal to 0. So this is equal to fb is equal to 0. And if we put fa here, a also, then this value minus this value is equal to 0. So for both a and b points, this is equal to 0. So here fa is equal to ab is equal to 0. So if we differentiate this function, we will get first derivative of fx is equal to minus first derivative of psi x plus phi b minus phi a by psi b minus psi a multiply first derivative of psi x. So since fx satisfies all the conditions of Rolle's theorem, we have earlier in this theorem taken all the conditions of Rolle's theorem, and here we will also getting fa is equal to ab is equal to 0. So we will get that a value of x belongs to the open interval a and b, which we are taking xi, for which first derivative of f xi is equal to 0, means first derivative of fx in the interval ab must be equal to 0. So for some xi in the interval closed interval ab, for which first derivative of fx is equal to 0. So if we will find out this, so we will get the result of Cauchy's mean value theorem for xi, which satisfying Rolle's theorem. For xi, we will get the Cauchy's mean value theorem, which we defined in this way. So we will get a value of x xi, for which we will get this form Cauchy's mean value theorem. Now we have for open interval a b of x, we will get phi x by psi x is equal to phi x minus phi a by psi x minus psi a, since phi x phi a is equal to psi a is equal to 0. So if we take this condition that phi a is equal to psi a is equal to 0, so we will get we can write down in this form phi x minus phi a, psi x minus psi a. So by Cauchy's mean value theorem, we can write down this is equal to we will get a value xi between this open interval ab. We have proved this. this will be phi, first derivative of phi xi by first derivative of psi xi. Now taking limit and noting that xi tends to a if x tends to a. Now since xi belonging to a and b and x also belonging to a and b, so if x tends to a, so xi must tends to a. So if we take limit in this equation, we will get limit x tends to a plus phi x by xi x is equal to limit xi tends to also a plus first derivative of phi xi by first derivative of psi xi is equal to limit x tends to a plus now since xi tends to a plus, we can write down x tends to xi plus first derivative of phi x by first derivative of psi x. So so in this way so here we getting a value xi which of x which is tending to a plus, so we will get x tends to a plus first derivative of phi x by first derivative of psi x. So in this way, if we take limit x tends to a minus phi x by xi x is equal to limit x tends to xi tends to a minus, if x tends to a minus, xi tends to a minus by first derivative of phi xi by first derivative of psi xi, and we can write down this is equal to x tends to a minus first derivative of phi xi phi x first derivative of psi x. So here we have taken x here we can write we can look that this is a function of xi, so this is replaced by just x. Since this is a function of xi, so we can replace it by x. So so since both limit exists and equals exists, then we can write down that since both limit exists, so we can simply write down limit x tends to a phi x by xi x is equal to limit x tends to a first derivative of phi x by first derivative of psi x. So this is called L-Hospital's rule. So you can prove in this way L-Hospital's rule. If you like this video, then like, share with your friends.